Hello friends, welcome to my channel. In this video, I will cover ISRO Technical Assistant 2015. This is third part. Question is, for pumps of same speed, discharge is proportional to speed is same. Pumps already I told. Power head and discharge proportional to n square nq. Then proportional to dq d square d to the power 5. So here in this question, discharge is proportional to this one. Discharge speed is same, so q is proportional to dq. So from option C is your answer. Question is, Francis turbine is best suited for. We know Francis turbine, it's a inward flow reaction turbine, medium head, medium speed, and mixed flow turbine, radial at inlet and axial at outlet. So medium head application from, this is your answer. A is your answer. For low head we are using Kaplan turbine, and for high head we are using Pelton wheel. So A is your answer. For small discharge and high heads, which pump is preferred? It's reciprocating pump. Small discharge and high head, centrifugal pump. High discharge, small head. This is also important. High discharge, small head. For a circular cross-section beam subjected to a shearing force F, the maximum shear is how much? So circular beam is like this. Force is coming like this. So this area is your shear area, or if you take the cross section here, it will come like this. This is your shear area. So we know shear is, stress is force for area. So area is here, it's circle area, pi by 4 d square, 4f by pi d square. So from option B is your answer. 29. Resilience of a material is important when it is subjected to, already told, resilience, strain energy, then your toughness, there for soft shock loading, and or you can call it as impact loading. B is your answer. Question is, 3 different weights fall from a certain height under vacuum. So if one object is falling, they will take same time to reach. We know time is, speed is distance for time, and time is distance for speed. So time is inversely proportional to speed. Distance is same for all three cases. So its speed from here to here, height is h. So speed or velocity we know 2gh root over. It depends only on h, function of h only. So it does not depends on the mass or weight. So height is same for all cases. So same time they will reach. Question is, the shearing stress in a helical spring of wire diameter small d and having mean diameter d supporting a compressive load F is given by what? So we know torque is pi by 16 tau s dq. Then torque is force into distance, or capital D by 2. Capital D is your mean diameter, mean coil diameter, pi by 16 tau s wire diameter Q. So from here tau s is 8ft divided by pi dq. Here one extra factor is there, k. K is constant. So 8ft by pi dq. This is your answer. C is your answer. Question is, a thin spherical shell of internal diameter small d is subjected to an internal pressure P. If sigma is the tensile stress for the shell material, then thickness of shell T is how much? So T value we have to calculate. Thin spherical shell, we know its circumferential stress or hoop stress. It's equal to longitudinal stress for spherical shell. So sigma C equal to sigma L. Its formula is very important. 4d by, it's PD by 4t. So from here sigma is the tensile stress, so it's equal to sigma. T value we have to calculate. T equal to PD divided by 4 sigma. So from option B is your answer. In the third angle projection, the object is imagined to be placed in. For third angle projection, we will keep the object in third quadrant, and for first angle projection, we will keep the object at first quadrant. So in third angle projection, here is the object, and for plan, projections we will draw like this. From top we will view it. It will come here. This is plan view. Then bigger circle. So for front view, from this side we will see it, this direction, front view. So it will come here. Like this it will come. And for first angle projection, plane is at bottom or back side. But in third angle projection, plane is in between viewer and your object. Here you will get, this is plan. Then for front view, you have to see from this side. It will come here. So in this question, for third angle projection, this is for third angle, this is for first angle. For third angle projection, object is imagined to be placed. Object is this one in red color. It's imagined to be placed below horizontal plane and behind vertical plane. This is vertical plane. This plane is your vertical plane. Behind the vertical plane, object is there. And for horizontal plane, it's below the horizontal plane. So from option below horizontal plane and behind vertical plane, A is your answer. But in case of first angle projection, object will be in between above horizontal plane and your question is front of vertical plane. This one. This is for first angle projection. And one more thing is important. Here in first angle projection, for first angle projection, if you see from this side, this is the object. Your plan will come here, back side of the object. And in case of third angle projection, if you see from this direction, it will come front of your object. These two are also important. Again I am repeating because this is very important. First angle projection symbol and third angle projection symbol. In first angle projection, it will come at back side, and in third angle projection, it will come at front of the object. So next question. An Oldham coupling connects two shafts when they are Oldham coupling, double slider crank return mechanism, third inversion of double slider crank, double slider mechanism. Then in this question it's Oldham coupling connects two shafts when they are parallel. B is your answer. This one already discussed. Symbol in drawing represents it's coming back side of the object, so it's first angle projection. But in case of third angle projection, it will come front of the object. Here it will come. This is for third angle projection. So answer is C. H7G6. Capital represents hole and small letter represents shaft. So this is your basic size or zero line. Then hole. This side, shaft. For hole. This is for shaft. This is zero line. Shaft, small letters start from A, B like this. Here you will get small h. Upper deviation 0. This is for small h. Then here this side it will go. And for hole, capital letters, capital A. For hole, H will come here with hole lower limit is touches zero line. In this question, it's capital H, so here it will come H7, then G6, G will come here. Minimum clearance is this one, minimum clearance, and for maximum clearance, this from here to here, this is maximum clearance. So both case you are getting clearance fit. So it should be loose fit or close running fit. Shrink fit means interference fit. Press fit also interference fit. So A is your answer. Push fit, I think it will come as transition fit, and shrink fit and press fit both are interference fit. Conic section obtained by cutting a right circular cone by a section plane inclined to the axis of cone and cutting all the generators. So you are cutting a cone for different cases. Conic section, right circular cone, we are cutting right circular plane by a plane parallel to its base. This plane is parallel to its base plane. If you cut, you will get a circle here. This is circle. Then in our case, you are cutting the cone in an inclined plane. This plane is inclined plane. So here you will get a ellipse. And for different case, you will get this is your plane which is parallel to a generator of the cone. This is parallel, both this line and plane line both are parallel. In this case you will get a parabola. If you cut in a inclined plane, you will get a ellipse and parallel to your generator, then you will get parabola. Here parallel to base circle, you will get your circle. All 3 points are important. So in this question, conic section obtained by cutting right circular cone by a section plane inclined to axis of the cone. So you will get your ellipse. For hyperbola, you have to cut the cone a plane parallel to the axis of the cone. This plane is parallel to the axis. This is your axis, cone axis. This plane is parallel to the axis. Then you will get hyperbola. This is also important. This is the end of part 3. Part 4 onwards I will cover in next video. Thank you friends. Thank you for watching my video. Thank you.